There's this incredible biological machine inside your head, one that takes invisible energy waves and turns them into music, into conversation, into the sound of your world. That's your ear. And today, we're going to follow the amazing journey of a single vibration as it becomes the sound you're hearing right now. It's a wild trip from pure physics to biology, and believe me, it happens faster than you can blink.
I mean, really think about it. Your favorite song, it starts out as just a little wobble in the air. How does that become a feeling, a memory? It's this incredible puzzle that our bodies solve every single second, and we're going to piece it all together right now.
So it all starts with this thing, the sound wave. This is pure physics. When something makes a noise, it sends out a pressure wave, like a ripple of energy, through the air. You can imagine it like a ripple in a pond, except it's totally invisible, and it's traveling at over 700 miles per hour. That's what your ear is up against. That's what it has to catch. Okay, so for that wave to become something you actually recognize as sound, it has to go on this remarkable 4-step journey inside your head. First, your ear has to collect it. Then, it needs to amplify it. After that, it has to convert it into a totally new language. And finally, your brain gets to perceive it. So let's start at the beginning with step 1. All right, part 1, the starting line. This is all about how your ear first gets a hold of that incoming sound wave. You know the part of your ear you can actually see? The pinna? Well, it's not just there to hold your glasses up. Its unique shape is basically a natural satellite dish. Its whole job is to catch all those sound waves and funnel them down a tunnel, the ear canal, towards all the important machinery hidden deep inside. And that brings us to part 2, the mechanical amplifier. The wave's been caught, right? But it's pretty weak. It needs a serious power boost. So at the very end of that ear canal, there's a thin, taut membrane. You know it as the eardrum. When those sound waves hit it, the eardrum does exactly what you think. It vibrates. Now this is a huge moment because it's the very first time that an invisible wave in the air has been turned into a physical, mechanical movement. And this is where the engineering gets absolutely incredible. That vibration gets passed to these things called the ossicles, the hammer, the anvil, and the stirrup. Get this, these are by far the 3 smallest bones in your entire body. And they're all linked together to form this perfect tiny system of levers, all designed for one critical job. So you might be asking, why this whole elaborate setup with tiny levers? Well, it's because the next part of the ear is filled with fluid, and trying to make a wave in fluid takes about 20 times more force than making a wave in air. The ossicles are the brilliant solution. They take that gentle vibration from the eardrum and they concentrate all that force into a powerful push, one that's strong enough to actually make waves in that fluid. And that powerful push brings us to the climax of our story, part 3, the incredible inner ear. This is it. This is where that purely mechanical motion gets transformed into the language of the brain itself, electricity. So, meet the star of the show, the cochlea. It's this amazing snail-shaped structure, and it's filled with that fluid we were just talking about. When the last of those little bones, the stapes, pushes against it, it creates these powerful waves that start to ripple through the fluid inside this incredible coiled tube. Now, lining the inside of the cochlea are the true heroes of hearing, thousands and thousands of microscopic hair cells. As the waves ripple through the fluid, they cause these little tiny hairs to bend. And right here, this is the moment of magic. That simple, physical bend triggers a tiny channel to open up and, bam, it creates a little electrical spark. The sound wave is no longer a vibration. It's now an electrical signal. This incredible moment actually has a scientific name. It's called auditory transduction. And it is, without a doubt, the single most critical step in this entire process. It's the moment of conversion from mechanical energy into the electrical language that your brain can actually understand. Without it, hearing just doesn't happen. Period. So, we've got our electrical signal. Now for the grand finale. Part 4, the final destination. How does that spark become a thought? That brand new electrical spark doesn't just hang around. It immediately jumps onto the auditory nerve. You can think of this like a biological superhighway, a high-speed data cable that runs directly from your ear straight to your brain. These signals zip along and arrive at the brain's auditory cortex. And here, your brain plays the part of the ultimate decoder. It takes this raw stream of electrical pulses and, almost instantly, it interprets them as your friend's voice or your favorite song or the wind rustling through the trees. This final act of interpretation, that is the moment you truly hear.
So let's just run through that incredible journey one last time. Step 1, the outer ear collects the sound. Step 2, the middle ear amplifies it to get it ready for the fluid. Step 3, the inner ear converts it from a physical vibration into an electrical signal. And finally, step 4, the brain perceives that signal as the sound you experience.
Which, leaves us with a pretty fascinating final thought, something philosophers have kicked around for centuries. If our brain is the thing that truly does the hearing, the perceiving, does a tree falling in a forest really make a sound if there's no brain there to complete the process? Kind of makes you think, doesn't it? Thanks for joining me on this one.